As we begin to dive deeper into polynomials, we're going to begin to look at the zeros and the factors of the polynomials, the building blocks. These pages somehow didn't make it into your packet, but they're some of the most important pages that we're going to do as we build towards where we're going with polynomials. So an introduction question is going to be what values of x would make this quadratic equal 0? Another way of thinking of that is equals 0. We're solving that equation right there. We could use quadratic formula, but instead we're going to see a lot more about it if we factor this polynomial. So if I look at him in terms of factoring, it's going to be a does not equal 1. Factors of ac, which is negative 60, that add up to b, which is negative 7. So I'm thinking that those numbers are going to be negative 12 and 5. So let me run through this process. I swap out the middle term for a negative 12x plus 5x. I still have the minus 20. We split him in half. We do GCF on each of these pieces. So I pull out the 3x, I get x minus 4. I have to get an x minus 4 on that side, and I do so by pulling out a 5. So this leaves me with 3x plus 5, and x minus 4 equals 0. That's just the factoring portion of what I'm doing. And then to get my solutions, to get my values of x, I have to use what I call the ZPP, zero product property. One of the most important properties in math. It's fairly straightforward. It says if I have two things multiplied together that equals 0, then I can just take each of the individual pieces and set them each equal to 0. And that's the way that I get my solutions. In this case, it's negative 5/3 and 4. There are two numbers that I could plug in that would make this original function right here equal to 0. Those two numbers are going to be super important as we move forward, not just as solutions to an equation, but also as parts of a graph eventually. So just a reminder of how I get through that process, and specifically this zero product property, ZPP. I'm going to refer to that a lot. So thinking about polynomials and what makes up polynomials, when we construct polynomials, we're really just multiplying together what we call factors. Little pieces that make up the larger polynomial once they're foiled together. So if I look at example 1 and I were to factor him, I factor it to see the factors, I have x plus 6 and x plus 4. There are two factors that make up that polynomial. So I have two, specifically, I'm going to call them linear because it's x to the first power, two linear binomial factors. Linear because they're the first, and binomial because there's two pieces. And normally we're going to break things into linear binomials. Not always, but normally. So this example, this polynomial here, the x squared plus 10x plus 24, is made up of two linear binomial factors. Those are his building blocks. If I come to example 2, it's another kind of factoring. It's actually difference of cubes. So if we factor that, according to our formula, I get x minus 1 and x squared plus x plus 1. You'll always have that formula. It's up on the wall if you need it, so you don't have to memorize that one. The key here is I have different types of factors. I do have a linear binomial right here. So that's a linear binomial, or just a linear factor. But then I also have this piece here, and he doesn't factor any further. You can't factor him with any of our methods. So he's going to be what we call a quadratic factor. So this cubic, this original cubic right here, is made up of a linear factor and a quadratic factor. So it has different building blocks. Lastly, example 3. We know how to factor the first step of this. We pull a GCF out of 3, and I get x to the third minus 7x minus 6. The next step, you don't know how to factor this yet. I'm just going to give you this information, so don't get confused by that. But if you were to break him down into all of his building blocks, he actually becomes x plus 1 x plus 2, and x minus 3. Those are all the building blocks of that polynomial. Where they come from doesn't matter right now. What matters is that I have 3 linear binomial factors. Three linear binomial factors. And then I just have this other factor of 3. I don't have any specific name for him. He's just a scalar factor out there. He's just multiplying everything by 3. He's not as important because he doesn't have an x with him. So you can start to see here how these different building blocks, when they're foiled together, will build up different polynomials. So a little bit of vocab as we keep going forward. We have what are called zeros of a polynomial, and we've already seen this. They're called the zeros or the roots. I'm going to use the same word, the same meaning, sorry, for both those words. So I'm going to say that any value, let me erase that 0 because that's not supposed to go there. Any value a is a 0 of the polynomial f of x if f of a equals 0. That looks confusing, but this is just saying if I plug the value into f, I get 0 out. That's all I'm saying. If I plug the value into f and I get 0, I'm going to call that a 0 of the function. So all I need to do to check it is just plug numbers in. So look at our example. We have f of x right here. Here's my function. And I need to plug in part a this negative 3/2 in and see if he's a 0. So I'm just finding f of negative 3/2. So I plug him in. It's going to look disgusting, but that's okay. I have negative 3/2 to the third, and that's minus 22 times negative 3/2 plus 35 times negative 3/2. And I plug that all into the calculator. You can do that on your own time. But the key is I'm just seeing, does it give me 0 or not? And in this case, it gives me as a decimal negative 112.125. The key is that that is not 0. So I'm going to say negative 3/2 is not a 0 of the function. He's not a 0 of the function. It doesn't make it equal 0 whenever he goes into the function. The zeros are special, and that's why we want to find them. On the other hand, if I do f of 5, if I plug 5 in for all the x's, so it'd be 3 times 5 to the third minus 22 times 5 squared plus 35 times 5. Plug that all into my calculator. I get f of 5 equals 0. When I plug in 5, I get out a 0. So that means I'm going to say that 5 is a 0 of f of x. He's a 0 of the function. He's one of those special numbers that when I plug it in, I get 0. If you come back up here and you look at it, that's what we found right here and right here. We found the zeros of the function, the two numbers that when I plug them in would make it equal to 0. So that's our first kind of vocab term, is the 0 of a function is the number. A 0 is a number that makes it equal to 0. So let's put all these ideas together, every single one of these ideas, and it's going to hopefully make some sense for us here in a second. So let's look at my example. I have a cubic function. And what I'm going to do is I'm going to factor that cubic function so I can see the pieces that make him up. So first thing I do is pull out a GCF. We're going to do a lot of factoring in this unit, a lot of factoring. So I pull out a 3x, and I'm left with 3x squared plus 8x plus 5. So it looks like I have some a does not equal 1 going on here. So I leave that 3x chilling out front because he's not going to factor anymore. And then I look inside right here and I do a is not 1. So to me, that looks like factors of, let's see, 15 that add up to 8. So it's going to be 3x squared plus 3x plus 5. Oh, I just jumped pages. Let me go back. scroll down, sorry about that, plus, ooh, it's not being fun at all, here we go, come on, plus 5x, sorry about that, plus 5. And again, I'm going to assume you can factor when a is not 1. You can take some time and finish that out if you want. The key is that I end up with a 3x plus 5, and I end up with an x plus 1. So I went through a factoring process. So again, that was GCF and a is not 1. That's how I got from there to there. The factoring process lets me see all of my factors. So lets me see all of my factors. So when I go through and I look at what the linear factors are, the x plus 1, he's pretty easy to see. He's linear because x is to the first power. The 3x plus 5, he's pretty easy to see because he's raised to the first power with the x there. It's this other one that's a little bit more difficult, and I'm going to say that the linear factor is just the x because he's to the first power. The 3 is just a scalar out front. He's just making everything 3 times larger. I don't care about him when it comes to linear factors. So there are 3 linear factors that made up this polynomial up here, 3 building blocks. One hint I always give is that anytime I say factor, it has to have some sort of x's. Factors have x's. And then to get from factors to zeros, I use that zero product property. So here I just say, well, x equals 0. So his 0 is 0. Here I say 3x plus 5 equals 0. So his 0 is negative 5/3. You subtract 5, divide by 3. Here, x plus 1 equals 0. His 0 is negative 1. So you have to start to get this in your head that zeros are numbers. Factors have x's, but there's a direct relationship between the two. You can go back and forth between one and the other using this zero product property as you move. So there's our first example of how zeros and factors build up these polynomials. We're going to continue in the next video with a couple more examples and talk about an idea called multiplicity.